We want to graph the linear equation x plus 2y equals 6 using a table of values. Now, one technique would be to determine the x and y intercepts, but for this video what we're going to do is select specific values of x and then determine the corresponding values of y, where each x and y value would represent a point on the line. So if we're going to select values of x to sub into this equation and then determine y, it's often helpful to solve the equation for y. So let's start by doing that. To solve for y, we'd have to subtract x on both sides of the equation. This would be 0. We're left with 2y equals, I'm going to write this as negative x plus 6. And then the last step to solve for y would be to divide everything by 2. So we'll divide this by 2, this by 2, and this by 2. So now we'll simplify, and the equation we'll use to complete the table is going to be y equals, instead of negative x over 2, I'm going to write this as negative 1/2 times x, and then 6 divided by 2 is equal to 3. And now looking at our table of values, the first column is going to be x, and the second column will be y. Now it is easier to graph points when the coordinates are not fractions. So we want to select values of x so that when we multiply here, the product will not contain fractions. So we want to select x values that would be multiples of the denominator, or in this case, multiples of 2. So we could select 0, 2, and 4 because these are all multiples of 2. Let's also select negative 2 and negative 4. Now we'll substitute these values into the equation and then determine the corresponding value of y. So when x is 0, we'd have negative 1/2 times 0 plus 3. That's going to be equal to 3. So the point where the x-coordinate is equal to 0 and the y-coordinate is 3 would be a point on the given line. Now we'll replace x with 2, so y is equal to negative 1/2 times 2, or 2 over 1, plus 3. Notice how the 2 simplify to 1, so we're left with negative 1 plus 3, that's positive 2. So the point with an x-coordinate of 2 and a y-coordinate of 2 would be on the given line. And now we'll substitute 4 for x. We have negative 1/2 times 4 over 1 plus 3. Again, the 2 and the 4 simplify. 2 simplifies to 1, 4 simplifies to 2. So this product would be negative 2 plus 3, which is 1. So the point when the x-coordinate is 4 and the y-coordinate is 1 is on the line. Next we have x equals negative 2, so we have negative 1/2 times negative 2 over 1 plus 3. Here's our common factor of 2 here and here. So this ends up being negative 1 times negative 1, which is 1, plus 3, which is 4. So the line contains the point where the x-coordinate is negative 2 and the y-coordinate is 4. And then for the last x value, we have x equals negative 4. So we have negative 1/2 times negative 4 over 1 plus 3. This simplifies again. There's 1 factor of 2 and 2, and 2 factors of 2 and 4. This is negative 1 times negative 2, that's 2, plus 3, that's 5. So the line contains the point with an x-coordinate of negative 4 and a y-coordinate of 5. Let's go ahead and plot these 5 points to verify they do form a line. 0, 3 would be here, 2, 2, right 2, up 2, 4, 1, right 4, up 1, negative 2, 4, left 2, up 4, and negative 4, 5, left 4, and up 5. Notice how these 5 points do form a line, which verifies our work is correct. This would be the graph of our linear equation. Where the equation of this line is x plus 2y equals 6, or solve for y, we had y equals negative 1/2 x plus 3. These two lines are equivalent, just written in a different form. I hope this was helpful.